Welcome everyone. In this video, we're building the Moz7 V2, and here you can see all the components we need. I'll walk you through each of the different products as we go through the video. The Moz7 V2 frame is a pretty complex frame with several integrated solutions. My build is going to differ a bit from the bind and fly version, so I'll have to get a little creative to find the best solutions. As you can see, everything comes nicely packaged in these small, slightly annoying plastic bags. But they've also included some really smart things. For example, a pre-made XT60 cable with a connector on the end and long SMA wires for the antenna mount. These are things that often become a problem on larger frames. There's also a pretty decent manual included, which shows which screws go where, along with a rough sketch of the different steps and what you should start with. Just keep in mind that this manual only covers the assembly of the frame itself. It doesn't take into account the components that will be installed along the way. And as a fun little bonus, you also get stickers featuring the different GEP-RC drones, including the one we're building right now. Unboxing this frame by itself could probably make a full video since there are so many parts, but I always like to unpack everything and lay it all out, so I get a good overview of what's included. You get a bunch of different screws. Luckily, all the bags are labeled and you can easily find the matching ones in the manual. But enough with the unboxing, let's get started with building the frame. Let's start with the bottom plate. Make sure that the press nuts are facing upwards. There are two reinforcement pieces that need to be mounted on the sides of the bottom plate. These can also be used to secure the battery in place if you want an underslung battery. So, these are the two screwdrivers I use the most when building drones, a 2.5mm and a 1.5mm hex screwdriver. But in this video, I'm going to test out a new screwdriver set from ATuMan. This is the X3 precision screwdriver set. It has 69 different bits and various other accessories. ATuMan reached out to me and asked if I wanted to test this set in my next build video. First impression is that it feels pretty premium. The screwdriver feels solid and well built, and there is no play or wobble, which you often get when the quality is not that good. From what I can see so far, the set includes all the bits you could ever need, at least for building drones. In addition to the bits, it also comes with a disassembly kit, typically used when you're replacing a phone screen and doing similar repair work. And finally, it also comes with a small magnetic screw organizer mat, really handy to have lying around the bench. This product is being launched now through a Kickstarter campaign, so check out the link in the description for a chance to get it at a reduced price. This frame comes with a heatsink for the VTX. The cables from the rear of the drone will run underneath it. I'm just mounting it now, but I expect I might have to take it off again later. The Moz7 is a dead cat frame, which means the longer arms are at the back and the shorter ones are at the front. They're clamped in place using two carbon fiber plates, and the screws go in from underneath. There are two screws on each arm, and you can feel the arms locking into each other when they're in the correct position. Okay, so at this point, I like to mount the motors. The motors this time are supplied by MEPS. They're from their Space series, the same ones I previously used on a 5-inch build, so I've had good experience with them. They are 2806.5 motors running at 1300 kV, designed for use with a 6S battery. I'll put a link to these motors in the description, and together with my discount code FRANK10, you'll get 10% off, which makes them very affordable. The motor protectors that come with this frame are made of TPU, which is a bit of a downside. I would have preferred if they shipped it with injection molded parts instead. TPU tends to flex when you're tightening screws, which means you can't tighten them as much as you'd like. Another thing is, you'll need longer screws. The screws that come with the motors aren't long enough, and GEP-RC didn't include any screws for this either. So if you buy this frame, make sure you have a stock of screws ready. I found that 14mm screws fit just right. I also use a washer on the screw to try and prevent it from digging into the TPU. I only had nylon ones, but ideally, I would have preferred steel. To protect the motor wires, they've included some protective plastic guards that you glue onto the arms, but I'm not really a big fan of those, so instead I'm using what I normally go for, which is PET braided sleeving. You can get it really cheap on AliExpress. It's a bit more work to get it on, but I think it gives the quad a much cleaner look. To get the wires in place without ripping the sleeving, I've developed my own little tool. I call it the penetration tool. One of the many useful accessories to have when building a drone is a good set of heat shrink tubing. I like to put a piece of heat shrink on each end of the sleeving to keep it nice and tidy. Finally, I secure it with zip ties. As you can see, it's a bit more time-consuming than just gluing on a plastic guard, but I think the result looks much better. So now that the motors and the motor wire protection are in place, it's time to install the ESC. The ESC I've chosen for this project is a SpeedyBee 4-in-1 60-amp ESC. It runs 8-bit firmware and can be flashed to Blu-ray. But before we can mount it, we need to figure out the stack screw situation. What I've noticed is that there are no proper stack screws included with this frame. The ones that come with it are way too short, and there are no nuts for the stack screws either. My solution is to use the stack screws that came with the ESC. They're exactly the right length so they don't touch the top plate. But it's pretty strange that GEP-RC didn't include any nuts for the stack screws. Usually they either have press nuts in the frame or include them. Luckily, I had some M3 lock nuts lying around that I can use. My plan is to route the motor wires underneath the ESC. This means I'll have to modify the side plates a little bit, but I think it's a good idea anyway to have some extra airflow in there. The capacitor that comes with the frame is a Rubicon 1000 microfarad cap, which is perfectly fine. They've also included a mount for it. It's meant to sit between the ESC and the VTX. The TPU part is extended so that it prevents the capacitor from shorting against the frame. On the bind and fly version of this drone, the cables run between the ESC and the FC. I think it's going to be tight enough with the XT60 cables there anyway, so I want to route them underneath the stack instead. As you can see, the XT60 cable that comes with it is too long, so it needs to be cut to the right length and bent around the capacitor. I'm mounting the TPU to the rear temporarily so I can make sure I get the correct length. A little extra focus here so I don't cut the XT60 cable too short. That's happened before. I pre-tin it very carefully. These wires really soak up a lot of solder, and if you give them too much, the whole cable becomes stiff and impossible to bend around the capacitor. Another challenge is that the TPU part holding the capacitor is very close to the pads. If it gets too hot, I risk melting it. I'm not completely satisfied with the amount of solder I got on the pad. I like to have enough so it just covers the contours of the wire and forms a nice round blob. I'll probably never be fully satisfied anyway, but I guess this is good enough. Just one to go. I use isopropyl alcohol to clean off the flux residue when I'm done. Next up are the motor wires. I've decided to run them underneath the ESC. That creates a few challenges, but it's already going to be quite tight up there with the camera cable and all the other wires. Another issue that can come up with the motor wires running over the ESC is unwanted electrical noise. In many cases, it works just fine, but I've experienced situations where the gyro picks up broadband noise coming from the motor wires. It's not the easiest way to solder the motor wires like this. If the cable bends too sharply, you risk cracking the insulation, and that's something we want to avoid. If the solder gets a bit stubborn, the solution is usually to just take your time and add a bit of flux. Now, to finish off the XT60 cable and the motor wires, I'm adding a layer of T8000 glue on the XT60 pads, since they're quite exposed here. Like I've said many times before, I really recommend everyone to keep a tube of this around. You can use it for almost anything. Here you can see I've test fitted the side plates and made the necessary cutouts for the motor cables. My camera forgot to record that part, but it actually went surprisingly smoothly, using an old soldering iron and a Dremel. Now I'm continuing with the frame. I'm installing the center standoffs and the TPU antenna mount before I start working on the air unit. The large, chunky antenna mount is designed to hold the XT60 connector, both VTX antennas and the ELRS antenna. I'm planning to use a receiver with 2 ELRS antennas. On larger drones, it often becomes a problem when the SMA pigtail is too short if you haven't planned for it in advance. With this frame, it actually comes with a long one included, which is a big plus. It also comes with 2 shorter ones intended for the air unit. To mount the XT60 connector, you use 2 6mm M2 screws along with the included nuts. Now all the antennas are in place and it's ready for the VTX installation. The VTX I've chosen for this drone is the best of the best, the DJI O4 Air Unit Pro. Recently, it's been a bit difficult to get hold of these, but Flywoo usually has them in stock. I've also heard that they ship to the US as well. What you need to keep in mind when using an O4 Pro in a 7-inch frame is that the MIPI cable for the camera is usually too short. As you can see here, if it were just a couple of centimeters longer, it would have fit, but luckily I've picked up a longer one, which we're going to install now. You start by opening up the air unit, which you'll need to do anyway to install the antenna. But be careful not to pull the cover off. There's a ribbon cable attached on the inside and you don't want to damage it. I'm removing the included antennas. I won't be using those. To disconnect the MIPI cable from the air unit, you'll need something small and pointed. I can actually use one of the tools from the ATuMan set, which, by the way, has been working great so far. Needless to say, you have to be careful. I doubt the warranty from DJI will cover it if you screw it up and break something. To open the camera, which is possibly even more fragile than the air unit, you need to remove the screw on top and gently pull it apart. You disconnect the cable here the same way as on the air unit. Try to remember how the cable is routed because the new one needs to follow the same path, so you can properly close the camera. The cable was glued in pretty tightly, so I used a bit of hot air to help it come loose more easily. Next, you remove the old cable from the camera housing and thread in the new one. When installing the new cable, make sure it's oriented the right way. You'll also hear a small click when it locks into place. It's also a good idea to add a few small dabs of glue, the same type I recommended earlier in the video. After you've screwed the camera back together, remember to push the small rubber piece back into place on the cable. It helps prevent moisture from getting inside. For the air unit, follow the same procedure and finish it off with a bit of glue there as well. If you're not getting any video after this, but you can still see the OSD in your goggles, there's a high chance the cable isn't properly seated and you'll need to open it up and check again. Now the air unit is ready to be installed in the frame, but before we can do that, we need to temporarily remove the heatsink it mounts to. The screws that GEP-RC included are too short to reach from underneath. Mount it the same way I'm doing here, otherwise the cutouts for the bind button and the memory stick port won't line up. Ask me how I know. Now is a good time to connect the cable from the VTX to the flight controller, since it becomes a lot harder to reach once everything is screwed in place. Before securing the heatsink, make sure no wires are getting pinched. We definitely don't want a half-cut motor wire. Now things are starting to come together. Next on the list is the flight controller, or the brain as some like to call it. Before I install the flight controller, I want the ESC to sit completely flat. As you can see, it's being pushed down slightly by the battery leads. I don't want that pressure to transfer up into the flight controller. To fix that, I simply use some nylon nuts to hold the ESC in place, along with a few M3 O-shaped silicone rubber shock absorbers. That also gives me a bit more space between the ESC and the flight controller. The flight controller I'm using for this build is also supplied by MEPS King. It's a T-Motor, or T-Hobby as they're called now, F7 HD flight controller. To be honest, I chose this flight controller before I had decided which frame to use it in. If I were to choose again, I'd probably go for a different one. Don't get me wrong, this is a very good flight controller. It has everything you need. It uses a BMI270 gyro with really solid built-in low-pass filtering, and it has a DJI port for the air unit. The challenge with using this in the Moz7 frame is that the USB port is on the wrong side. The Moz7 frame only has cutouts in the side panels for a USB port on the right-hand side. I could rotate the flight controller 180 degrees, but even then it wouldn't line up with the cutouts, since this USB port sits quite high. The solution is to make a cutout in the left side plate instead, just like I did for the motor wires. So, instead of buying this one, I would probably go for the T-Hobby Velux F7 2nd edition flight controller. It has the USB port on the right side, and it's also bottom mounted, which means it lines up much better with the cutouts on the Moz frame. Nevertheless, I'm still going to mount this one and just deal with making an extra cutout. One thing you need to watch out for when using an ESC and a flight controller from different brands is that the cable pinouts match. You can usually find the information you need in the manuals for the components, and if it doesn't match, you'll need to modify the cable. That is actually pretty straightforward, as long as you have a fine pair of tweezers. Use the included nylon nuts to secure the flight controller. You don't want it too loose or too tight. The sweet spot is when the rubber grommets are just slightly compressed. The receiver I'm going to install is the Radiomaster XR4 receiver. It has diversity and supports the Gemini protocol. That means it supports both Express LRS 2.4 GHz and 900 MHz, and if you have a radio that supports Gemini, you can take advantage of automatic switching between the two. On the Moz frame, it's designed so the receiver is mounted in the front. It comes with a mount that fits the XR4 receiver, and the long antenna cable from the rear antenna reaches perfectly when mounted here. The second antenna is mounted in the front underneath the camera, so there's no need for a long cable. The small round spot on top of the mount is meant for a beeper, the type without a battery. I'll be using a different kind. I'm planning to use UART3 for the receiver. RX3 also doesn't share the S-bus pad with the DJI plug, so I don't need to worry about removing the yellow wire from the air unit. There's no 5.5 volt pad on this flight controller, so I'll need to plug in the battery to power up the receiver. On the plus side, it does have a switchable 9 volt BEC, so I can turn off the VTX while working with the drone on the bench. The forward receiver antenna is meant to be mounted under the camera on a separate TPU part, but first we need to install the plates that make up the camera housing. As you can see, the antenna fits very loosely. This TPU part is most likely designed for a specific GEP-RC antenna form factor. Loose antennas are not something I can live with, so I'm fixing it with an M2 rubber grommet and some heat shrink. I could of course have downloaded the STL file and remixed it, but this method works just fine too. Anyway, now the antenna is sitting nice and secure, and I can continue with mounting the O4 camera. Before we can install the camera, we need to mount the 23mm horizontal standoff. The frame comes with two different soft mounts for the camera, one made of regular TPU and one made of silicone. For the O4, which is quite sensitive to noise, we're going with the silicone parts. A good tip is to always make sure the camera is mounted the right way, so you don't end up with an upside-down image in your goggles. I have to say, this screwdriver from ATuMan is really growing on me. I'm pretty sure this is going to become my daily driver when it comes to screwdrivers. So I'm finishing up the camera installation with the cute golden top cover and the GoPro mount. These two can also be swapped around if you want, as you can move the GoPro mount further forward. Now things are getting close to being finished. The only two things left are the GPS and the beeper. I'm putting on the side plates so I can figure out a good place to mount the beeper. I'm not really a fan of side plates, but these are easy enough to take on and off, so it actually makes more sense. I've dealt with side plates before, where you basically have to dismantle half the drone just to remove them. Hint, iFlight. Alright, so the beeper I'm using isn't just a beeper. It also works as a GPS mate, meaning it can power the GPS just by switching it on. The advantage of that is you can warm up the GPS without plugging in the main battery, and you also don't lose GPS lock when you swap batteries. It works like this. You connect the GPS to this unit, and then you run the wires from the GPS mate through to the flight controller. It's clearly labeled on the back, showing exactly which wires go where. My challenge here is that this frame is absolutely not designed for a beeper like this, so to mount it in a sensible way, I'm going to have to add an external switch to the beeper. I'm starting by carefully removing the original switch. This is a press and hold switch, so it doesn't need anything fancy. A simple push button will do the job. My plan is to solder on 2 small wires so I can mount the beeper inside the drone and have the switch accessible at the back. The switch I'm using is a tacked push button from AliExpress. It costs less than $1. Now I have a fully functional GPS mate and beeper with an external switch ready to be mounted at the back of the drone. I want the button to be easy to access. The worst thing I know is having to search for the beeper button just to disarm it. So I'm drilling a hole for it at the back of the TPU antenna mount. Drilling a clean hole in TPU isn't that easy, so I quickly realized I had to bring out my old, ugly soldering iron. I think that will work, and then I'll glue it in place from the inside. The GPS mount that comes with the Moz7 frame is huge. My full-size GEP-RC Pro GPS looks like a mini GPS inside it. To solve that, I designed my own GPS mount using the same mounting interface as the Moz7 mount. I've uploaded it to my MakerWorld profile if you're interested. I need to cut and solder the wires for the GPS since the plug on the GPS cable isn't compatible with the GPS mate. So I make sure I leave enough cable length so I can bend the GPS backward. Sorry for the change in lighting. I just realized I forgot to turn on my work light since I couldn't really see anything. Now finally, I'm ready to solder the GPS to the GPS mate and the GPS mate to the flight controller. Since there are a total of 7 wires going from the GPS mate to the flight controller, I'm splitting it into 2. One cable for 5 volts, ground and buzzer, and another for RX and TX, plus the 2 wires for the compass. I'm using a slightly thinner braided sleeving on these cables. It keeps everything looking neat and tidy. I want the wires routed under the flight controller. I generally prefer that whenever possible. It looks cleaner and the wires aren't sitting there vibrating or interfering with the gyro. I know some of you are going to ask, if those solder joints are bridged. They're not. It just looks like that because of the flux between them. I'll clean that up at the end. Now, all the components are in place, and it's time for a smoke test. A smoke test is always a good idea, even if you're confident in your soldering and the work you've done. In some cases, a faulty component can still cause a short circuit. Before I plug in the battery, I install the antennas. The VTX antennas are 13 cm long, left-hand polarized antennas from GEP-RC, and the receiver antenna is a tri-band stick antenna from GEP-RC. I also check that the GPS mate is working. The switch I installed on the side works well and the GPS powers on when I hold the button down. I'm using a smoke stopper from SpeedyBee. It shows the battery voltage and lets you limit the current all the way down to 1 amp. It works really well. Everything is looking good. There's just one last thing I forgot before I can screw the top plate into place. I need to make a cutout for the USB port. To do that, I use an old soldering iron and finish it off with a Dremel to clean it up. The drone is now finished and all that's left is to mount the top plate and the propellers. So what do I think about this frame? You might be wondering. I think it's a solid frame, but a bit challenging due to all the custom design choices GEP-RC has gone for. That said, it's definitely grown on me throughout the build process. The battery pad that comes with it is the sticky type, which is really good. It also comes with a battery pad for the bottom plate if you want to mount the battery or other gear underneath. For props, I've initially gone with 7.5-inch props from HQ Prop. Even though this frame is rated as a 7-inch frame, it actually supports 7.5-inch propellers. The battery I'm going to test it with is my homemade 6S2P 6000 mAh pack, and if you're interested, I'll soon be making a video reviewing a new spot welder from FPV and building a new battery, so make sure to subscribe so you don't miss it. And since I know you're going to ask, the weight without the battery is 800 grams, and with the battery it comes in at 1,431 grams. Now it's ready for the first test flight. This is before I've done any tuning, just the basic setup in Betaflight. I can already see the GPS mate doing its job, 24 satellites, right after plugging in the battery. I expect this GPS will eventually lock onto closer to 40. The drone flies smooth, and there is no jello visible in the camera feed either. Looking forward to tuning this one and getting it properly locked in. I can see I forgot to adjust the low battery warning threshold since I'm now flying a lithium-ion battery. With that, I'm signing off for this time. If you're still here watching this very long build video, then you're exactly the kind of person I hope will subscribe. Thanks for watching. See you in the next one.